Hello, my dear. Let's start our astronomy course. Okay, Martin, please. So, earlier you began study of planetary astronomy by pondering evidence about uh, how our solar system works. In the two lectures that followed, you uh, surveyed the planet and found more clues about the origin of the solar system. However, most traces of planets' earliest histories have been erased by geological activity or other processes. Now you are ready to study smaller, better preserved objects that can tell you more about the age of planet building. Compared with planets, the comets and asteroids are unevolved objects, leftover planet construction bricks. You will find them much as they were when they formed 4.6 billion years ago. The fragments of these objects that reach Earth can give you a close look at these ancient planets. As you explore, you will find answers to four important questions. Where do meteors and meteorites come from? What are asteroids? What are comets? And what happens when an asteroid or comet hits Earth? You are not a ghost. People viewed them with terror. For example, in 1910, Comet Halley was spectacular. On the night of Afraid of Comets, of course, but not long, May 19, 1910. Those actually passed through the tail of the comet, and millions of people panicked. The spectrographic discovery of cyanide gas in the tails of comets led many to believe that life on Earth would end. Householders in Chicago stuffed rags around doors and windows to keep out the gas, and bottled oxygen was sold out. Con artists on taxis sold comet pills and inhalers to ward off the noxious fumes. Another part of USA and Oklahoma newspaper reported in what was apparently a hoax that a religious sect tried to sacrifice a virgin to the comet. Throughout history, bright comets have been seen as a portent of doom. Even the more recent appearance of bright comets has generated predictions of the end of the world. Comet Kogoldek in 1973, Comet Halley in 1986, and Comet Hale-Bopp in 1997 caused concern among the superstitious. A bright comet moving slowly from night to night against the stellar background is so out of the ordinary that you should not be surprised that it can generate some instinctive alarm. In fact, comets are graceful and beautiful visitors to our sky. Astronomers think of comets as one type of messenger from the age of planet building. By studying comets, you can learn something about conditions in the solar nebula from which planets form. Comets, however, are only the remains of the icy parts of the solar mass. In contrast, asteroids are rocky debris also left over from planet building. Because you cannot easily visit comets and asteroids, you can begin by learning about the fragments of those bodies that reach Earth, meteors and meteorites. You learn something about meteorites when you study the age of the solar system. There you saw that the solar system is filled with small particles called meteorites. Some of them collide with Earth's atmosphere at speed of 10 to 40 kilometers per second. Friction with the air heats the meteoroids enough so that they glow, and you see them vaporize as streak across the night sky, called meteor. If a meteoroid is big enough and strong enough, it can survive its plunge through the atmosphere and reach Earth's surface. Once the object strikes Earth's surface, it is called a meteorite. The largest of these objects can blast out craters on Earth's surface, but such impacts are rare. The vast majority of meteorites are too small to form craters. These meteorites fall all over Earth, and their value lies in what they can reveal about the origin of the planet. Meteorites can be divided into three broad categories. Iron meteorites are solid chunks of iron and nickel. Stony meteorites are silicate masses that resemble Earth's rock. Stony iron meteorites are mixtures of iron and stones. These types of meteorites are illustrated in this slide. Iron meteorites are very dense. They often have dark, rusted surfaces and complicated shapes caused by their passage through the atmosphere. When they are sliced open, polished, and etched with acid, they reveal regular bands called Wittgenstein patterns. Let's look at this slide. The patterns arise from crystals of Nickolay alloys that have grown large, indicating that the meteorite cooled from molten state no faster than a few degrees of temperature per million years. Learning later in this lecture how iron meteorites could have cooled so slowly will be a major step in understanding their history. Stony meteorites, called chondrites, pronounced chondrite, and have chemical compositions that closely resemble a cooled lump of matter from the sun with the helium and much of the hydrogen removed. Most types of chondrites contain chondrules, rounded beads of glassy rock ranging from microscopic to several millimeters across, as you can see at this slide. Details of the origin of chondrules are unclear, but they appear to have formed in the young solar system as droplets of molten rock and cooled and condensed rapidly. The presence of chondrule particles inside chondrite meteorites indicates that those chondrites have never been melted since they formed, because melting would have destroyed the chondrule. Some chondrites contain volatiles and organic or carbon compounds and may have formed in the presence of water. Carbonaceous chondrites are especially rich in volatile and organic substances and also have chondrule. Other type of chondrites, in contrast, appear involatile. The condensing solar nebula should have incorporated water plus other volatile and organic compounds into solid particles as they fall. If that material had later been heated, it would have lost the volatile and many of the organic compounds would have been destroyed. The special significance of carbonaceous chondrite meteorites is that they include some of the least modified material in our solar system. Some stony meteorites contain no chondrule, and they are called achondrites. They also lack volatile and appear to have been subjected to intense heat that melted chondrules and completely drove off the volatile, leaving behind rock with composition similar to Earth's lavas. Stony iron meteorite appears to have formed when a mixture of molten iron and rock cooled and solidified. This type of meteorite also contains no chondrules or volatile. The different types of meteorite also contains also have had a wide variety of histories. Some chondrites were heated, but not melted after they formed. Others somehow avoided being heated at all. Some achondrites seem like pieces of lava flows, whereas stony iron and iron meteorites apparently were once deep inside to the molten interior or differentiated objects. Meteorites provide evidence that the early history of the solar system was complex. On any clear, moonless night of the year, you might see a few meteors around, but these usually would not be coming from the same direction and are not related to each other. On some special nights, each you can observe meteor showers, displays of meteors that are clearly related in a common origin. For example, the Perseid meteor shower occurs each year in August, and during the height of the shower, you could see as many as 40 meteors an hour if you stretch out on a lawn chair at a dark side and watch the sky long enough for your eyes to adopt the dark. During a meteor shower, you will see meteors that are related in that they seem to come from a single spot of the sky. The Perseid shower, for example, appears to come from a spot in the constellation Perseus. These showers are seen when Earth passes near the orbit of a comet. The meteors in meteor showers are understood to be produced by dust and debris released from the icy nucleus of the comet. The meteors appear to come from a single place in the sky because they are particles traveling along parallel paths through space. Like railroad tracks extending from a point on the horizon, the meteors appear to approach from one point in space, as you can see at this part, on the left part of this slide. The orbits of comets are filled with such debris. The infrared astronomy satellite, IRAS space telescope, detected some warm dust glowing at far infrared wavelengths scattered along the orbit of several comets. Studies of meteors show that most of the meteors you see on any given night, whether or not there is a shower, right, are produced by tiny bits of debris from comets. These specks of matter are so small and so weak they vaporize completely in the atmosphere and never reach the ground. But from their motion, astronomers can deduce their orbits, and those orbits match the orbits of comets. And thus, nearly all visible meteors come from the comets. It is a common misconception that a bright meteor disappearing behind a distant hill or line of trees probably landed just a mile or two away. This has triggered hilarious wild goose chases as police, fire companies, and TV crews try to find the impact site. Almost every meteor you see burns up to 80 kilometers or more above the Earth's surface. Only rarely is an object strong enough to reach the Earth's surface and be considered a meteorite, landing as much as 100 miles from where you are standing when you see. Evidence suggests that in contrast to meteors, meteorites are fragments of foreign bodies that were large enough to grow hot from radioactive decay or other processes. They then melted and differentiated to form iron-nickel cores and rocky mantles. The molten iron cores would have been well insulated by the thick rocky mantles, so that the iron would have cooled slowly enough to produce big crystals that result in Widmanstanten patterns. Collisions could break up such differentiated bodies and produce different kinds of meteorites, as you can see in this slide. Iron meteorites appear to be fragments from the pattern parent body's iron core. Some stony meteorites that have been strongly heated appear instead to have come from the mantles or surfaces of such bodies. Stony iron meteorites apparently come from boundaries between stony mantles and iron core. In contrast, chondrites are probably fragments of smaller bodies that never melted, and carbonaceous chondrites may be from such unaltered bodies and formed especially far from the sun. This hypothesis traced the origin of meteorites to planet Mars-like parent bodies, but they leave you with a past. The small meteoroids now flying through the solar system cannot have existed in their present form since the formation of the solar system, because they would have been swept up by the planet in a billion years or less. Okay? They could not have survived for 4.6 billion years. In fact, when astronomers study the orbits of meteorites, actually seem to fall, the orbits lead back into the asteroid belt. And thus, astronomers have good evidence that the meteorites now in museums all over the world must have been produced by asteroid collisions within the last billion years. Nearly all meteors are pieces of comets, but meteorites are pieces broken off asteroids. How can you say that meteors come from comets, but meteorites come from asteroids? First, remember the distinction between meteors and meteorites. A meteor is a streak of light seen in the sky when a particle from the space is heated by friction with Earth's atmosphere. A meteorite is a piece of a space material that actually reaches the ground. Okay? The distinction between comet and asteroid sources must take into account two very strong effects that prevent you from finding meteorites that originated in comets. First, evidence is that cometary particles are physically big, and they vaporize in Earth's atmosphere easily. Very few even reach the ground, and you are unlikely to find them. And second, even if a cometary particle reached the ground, it would be so fragile that it would wear away rapidly. And again, you would be unlikely to find it. Asteroidal particles, however, are made from the rock and metal and are strong. They are more likely to survive their plunge through the atmosphere and more likely to survive erosion on the ground. Every known meteorite is from the asteroid. Not a single meteorite is known to be cometary. In contrast, meteor tracks show that most meteors you see come from comets, and very few are coming from the asteroid belt. Now build a new argument. What evidence suggests that meteorites were once part of larger bodies broken up by impact? I think it's enough for today. Next lecture will be devoted to asteroids. And for this moment, I think you enjoyed this lecture, and I'm looking forward to see you next time. Bye.